Greetings, sir. My course project is on Q1 mass damper. Coming to contents of my PPT, starts with introduction and why we are using TMD, design process of TMD, principle of TMD, applications, then conclusions and references. So coming to introduction part of TMD, a tuned mass damper is a device which consists of a spring, a mass and a damper, and it is attached to a structure in order to reduce the dynamic response of it. The frequency of the damper is tuned to a particular structural frequency, so that when frequency is excited, the damper will resonate out of the phase with the structural motion. Then energy is dissipated by damper, inertia force acting on the structure. TMD is preferred to place where the structural deflections are the most. Then coming to the next slide, the purpose of using TMD. It is used to reduce the action of earthquake in the seismic areas to provide mitigation against the wind forces. Then coming to the next content, the design process of TMD. TMD is used to measure the frequency and the magnitude of the undesirable motion. Then to develop model of existing structure and determine the TMD mass and placement of TMD to achieve vibration mitigation requirement. And to perform protocol testing of the TMD to find the tune design. Then measure the motion of the TMD on the structure to confirm performance and that the mitigation objective was achieved. Basically, TMD is divided based on its control mechanism. Initial one is active mass damper, then it's passive mass damper. Active control system is one of active control system is one in which an external power source of the control actuators are used that apply forces to the structure in a prescribed manner. These forces can be used to dissipate energy from the structure. You can have a look at the diagram of active mass damper here. Then coming to passive mass damper, it is a system that does not require an external power source. Passive control device impart forces that are developed in response to the motion of the structure. So the total energy cannot increase, hence inherently stable. Then coming to the general principle of tamped mass damper, tuned mass damper. The damper consists of a mass M2 and a spring K2 of damping constant C2. Then the value of M2 and K2 are chosen so that the moving part of the damper can be tuned properly to the structure frequency. There is a free body diagram of TMD. Then coming to the applications part, tuned mass dampers are mainly used in following applications: tall and slender free-standing structures like skyscrapers, chimneys, bridges, and TV towers, and bridges in pedestrian bridges also. Here are some real-life examples: City Crop Center in New York and John Hancock Tower, Boston CN Tower in Toronto, Chiba Park Tower in Japan, the world's largest building in the present generation, the Burj Khalifa, which is equipped with 11 different TMDs to control the vibrations. Here I am concluding my course project on TMD. As we conclude it is very much evident that with certain drawbacks, TMDs are very effective tool to protect the structures from various lateral forces like wind forces, earthquake effects, and thereby it can save our property and priceless lives. Here are the references which I used. Thank you.